If you have set your mind on using GraphQL or REST, then the choice of AppSync versus API Gateway is perhaps moot. But I know many of you don't feel strongly about either GraphQL or REST. What you need is a service that can cater for your specific functional and non-functional requirements. If that's the case, then this lesson might help you make the right decision between AppSync and API Gateway. As discussed in the previous lesson, AppSync is a fully managed GraphQL service. It has built-in support for caching, monitoring, and logging, and it supports WebSockets through GraphQL subscriptions, which can scale to millions of connected clients. AppSync has built-in integration with AWS WAF, or Web Application Firewall, which is a service that lets you configure firewall rules for your API, and has many built-in rules you can enable that can block suspicious IP address or requests that are missing some headers or authentication, and you can also configure IP-based rate limiting rules as well, which can block some naive denial of service attacks. AppSync has direct integration with a number of AWS services such as DynamoDB, RDS, and Elasticsearch. And you can write GraphQL resolvers that talk to these services directly. For anything else, you can always use a HTTP resolver to integrate with existing REST APIs, or a Lambda resolver if you need to write custom code or execute more complex business logic. In terms of authentication and authorization, it supports Cognito user pools, AWS IAM, API keys, and OpenID Connect for working with any OIDC compliant services. API Gateway is also a fully managed service, but it's more for REST APIs, although it supports WebSockets as well. And like AppSync, it also has built-in caching and monitoring and logging support. And yes, it also has direct integration with AWS WAF. There are direct integration with most AWS services. However, this often requires you to write quite a bit of custom VTL code, which is not everyone's cup of tea and is difficult to test. In most cases, you probably end up using the Lambda proxy and implement your REST endpoints using Lambda functions. But in case you're wondering why and when you should consider using API Gateway service proxies, then check out this blog post, where I discuss the why, when, and how of API Gateway service proxies. In terms of authentication and authorization, API Gateway supports all the different options that AppSync does and some more. It supports Lambda Authorizer, which you can use to implement custom authentication logic. And its API keys also support the rate limiting and quotas, which is very useful for SaaS applications where you often need to limit how many API requests a client can make per month. It supports custom domain names, which AppSync doesn't support right now, and you can create private endpoints that are only accessible through your own VPCs, which is another thing that AppSync doesn't support. And finally, it supports resource policies, which, amongst other things, lets you implement allow list and the deny list by IP address, which is useful for B2B applications where some of the more modern authentication options are not available, and you can only log down access to your API by known IP addresses. So in terms of the overall feature set, API Gateway has a few more things in its locker compared to AppSync, with quite a few useful features that AppSync doesn't have just yet. But there are a couple of things that AppSync does significantly better than API Gateway. For example, if you need to implement group-based authentication, where you need to model different access levels, for example, admin users can do everything, but other users have read-only access. Within Cognito, you can create groups and put users into those groups, and you can also associate each group with an IAM role, and a precedence value for selecting which group is applied for permissions if a user is in multiple groups. However, when you use the Cognito authorizer with API Gateway, this IAM role and precedence is not applied automatically. API Gateway only checks if the user belongs to the Cognito user pool. It doesn't perform any checks against the groups or use the IAM role associated with the groups in any way, so to implement group-based authentication, you have to do it yourself. First, you need to assign IAM role to each group to control which endpoints a user can access. Then, make sure you set the precedence on these groups so you can pick the most appropriate one if a user belongs to multiple groups. And then you have to write a Lambda authorizer, and that's right. To implement group-based authentication with Cognito, you can't actually use Cognito as authorizer. You have to write custom authentication logic, and you need the Lambda authorizer for that. And the Lambda authorizer needs to validate the authentication token with Cognito to make sure that the user actually belongs to the user pool, and then get the user details so you know which groups the user belongs to. And based on the precedence on those groups, pick a group for this user and generate a policy based on the IAM role that's associated with the group. So if this sounds complicated, it's because it is, and it's hard work. Whereas in AppSync, group-based authentication with Cognito is built in. You can just say in the GraphQL schema what groups can perform an operation, and that's it. Done. It's effortless and self-explanatory. Another requirement that often pops up is request and response validation. API Gateway does support request validation. You need to specify the request schema for an endpoint, and if a request fails request validation, then you don't pay for it, which is great. It's a good way to protect you against some naive attacks, but there's no response validation, even though you can specify a response model, but that model is only used for documentation purposes. To implement response validation, you have to do it inside your code, perhaps using things like MIDI, which is a middleware engine for Node.js functions, which is a language-specific solution, and there might not be an equivalent to MIDI in other language runtimes. Response validation is often overlooked, but it's actually a really important tool for preventing data leaks. For example, if we just read an object from DynamoDB and return everything, maybe there are data points that shouldn't be returned, like date of birth, or address, or credit card numbers. Or if an attacker has successfully executed a SQL injection attack against us and tricked our API into returning everything we had in the database. And security is as much about what your application should do as what it shouldn't do. It's entirely possible for you to do a good job of request and response validation with API Gateway, but once again, it's hard work and it's work that you have to do yourself, so it often goes by the wayside or it is forgotten. And the good news for GraphQL and AppSync is that request and response validation is built into how GraphQL works. The client can't ask for any data that's not on the schema, nor can the server return any data that's not on the schema neither. And if there are data points that should only be returned when I view my own profile, but not when other people view my profile, then I can simply define two separate profile types in my GraphQL schema, one for private and one for public. And make sure that search and other operations always return public profiles and therefore eliminate the risk of accidentally return a user's private information. And finally, let's talk about Websockets. Both AppSync and API Gateway support Websockets, but the developer experience with them are quite different. API Gateway has had WebSocket support since 2018, and the way it works is that when someone connects to a WebSocket API, you can use a Lambda function to handle the onConnect event, and if you want to use that connection later to send message to the user, then you have to record the connection ID somewhere, maybe in a DynamoDB table. And if you're building, say, a chat app where you want to send push notification to everyone in a group, whenever one of the group members sends a new message, then you also need to map the connection ID against the group ID. And equally, whenever a user disconnects from the WebSocket API, you can use the Lambda function to handle the onDisconnect event and update your records in DynamoDB accordingly. And when you need to send messages to a WebSocket connection, you have to first fetch it from DynamoDB, where you saved it during the onConnect handler function, and then make a request to API Gateway to say, please send this message to this connection ID. So as you can see, API Gateway's WebSockets is a very low-level construct where you have to manage and store the connection IDs yourself in order to send messages to those connections later. And there are no built-in support for broadcasts, so if you need to broadcast messages to, say, millions of connected users, then well, you need to first get all the connection IDs from a database, and then make a million API requests to API Gateway, because you can only send one message to one connection ID per request. So if you need broadcasts, this is super inefficient and would not scale well. That being said, it's still fine for simple use cases where you need to send messages to a small group of users at a time, for example, one-to-one private chats, or even group chats where you can limit the size of the group, but still is fairly limited. By comparison, WebSockets in AppSync is a breeze to work with. It's all tied up with subscriptions, which you can define in your GraphQL schema. First, you define a mutation operation in the top-level mutation type to capture the updates that you want to push to subscribers. Then you define the top-level subscription type and add the things that clients can subscribe to. In this case, I want clients to be able to subscribe to new posts that are added. So I connect the subscription with the mutation, and when a client subscribes to this added post subscription, then every time I make an add post mutation, the resulting post object will be sent to the subscription and broadcast to all the subscribers. What's more, you can add arguments to the subscription operations, so it allows the subscribers to choose what events to subscribe to. Rather than having to receive every update, I can say, only send me updates for a particular event ID, or if a particular author has created a new post, and so on. So WebSockets in AppSync is much easier to use compared to API Gateway, and the fact that it is also a higher level construct and supports broadcasts out of the box makes it easy to build application features on top of when you don't have to deal with the underlying connections yourself. And it can scale to millions of connected clients, so it's suitable for even the more demanding applications out there. So I hope this lesson has given you a good idea how AppSync compares to API Gateway, and perhaps when you should use which. But it doesn't have to be one or the other. You can also use them side by side, and later in the course, we'll talk about some of the use cases for using API Gateway with AppSync. And we will also look at how to use subscriptions to implement certain features in our Twitter clone.